So this is a bit of a trial of today's lesson that we did. Some of you might want me to go over it one more time. So here's exercise 14.3 skills, page 283. So we have to find the roots of this equation, that is to say, to factorise and to solve, to see where these x values actually cross the x-axis, in other words the line y equals 0. So if you factorise that, you get these two factors you can clearly see, therefore x equals 0, and x plus 7 also equals 0, and therefore x must be minus 7. So the two roots, the two crossing points, are 0 there and minus 7. Now the line of symmetry between 0 and minus 7 is clearly the line x equals minus 3.5. What you can then do is then take this x value of the line of symmetry, because you know it passes through the minimum points just there, because the minimum points is where the turning point is, so we can actually work out that coordinate. If you substitute minus 3.5 into the equation there and there, you'll end up with minus 3.5 all squared plus 7 lots of minus 3.5. That completely fits that. And if you pick up your Casio, you get minus 12.25 or minus 12.25. That's called the minimum value. The graph will never go below minus 12.25 or minus 12.25. So what is the actual coordinate? Well, the minimum value is minus 12.25, and at that point the x value is minus 3.5. Hence the point exactly there where the line of symmetry passes through the graph at the turning point is minus 3.5 for the x and minus 12.25 for the y. So that's the turning point. It is a minimum value. It's a minimum turning point because the graph won't go any lower than that. If the graph was a minus x squared graph and may look something like that, then that will have a maximum, and the turning point will be a maximum. So that's that. Let me pause that and see how that sounds and looks. I'll probably upload it to YouTube and see if you can access that from home. All right.